Hello everyone. Hello everyone. My name is Vinay Kumar. Today I'm going to talk about algorithm for finding factorial. Before that, let's talk about algorithms. What is an algorithm? An algorithm is a procedure used for solving a problem or performing computation. Algorithm can Algorithm acts as a precise list of instructions that conduct specified actions step by step in either hardware or software-based routines. Algorithms are widely used throughout all areas of IT. In mathematics and computer science, an algorithm usually refers to a small procedure that solves a recurrent problem. Algorithms are also used as specification for performing data processing and play a major role in automated systems. An algorithm could be used for sorting sets of numbers of a more complicated task, like recommending user content on social media. Algorithms typically start with initial input and instructions that describe a specific computation. When the computation is executed, the process produces an output. How do algorithms work? Algorithms can be expressed as a neutral language. Programming languages, pseudocodes, flowcharts, and control tables, natural languages expressions are rare as they are most ambiguous. Programming languages are normally used for expressing algorithms executed by computer. Algorithms use an initial input along with a set of instructions. The input is initial data needed to make decision can be represented in the form of numbers of words. That input data gets put through a set of instructions for computation, which can be include arithmetic and decision making process. The output is the last step in algorithm and is normally expressed as more data. For example, a search algorithm takes a search query as input and runs it through a set of instructions for searching through a database. For relevant item to query, automation software acts as another example of algorithm. As automation follows a set of rules to complete tasks, many algorithms make up automation software and they all work to automate a given process. What are different types of algorithms? There are several types of algorithms, all designed to accomplish different tasks. For example, search engine algorithm. These algorithms takes search engine search strings of keywords and operators as input, searches its associated database for relevant web pages, and returns the results. Encryption algorithm. This computation algorithm transfers data according to specified action to protect it. As a symmetric key algorithm, such as data encryption standard, for example, uses the same key to encrypt and decrypt data. As long as the algorithm is sufficiently sophisticated, no one lacking the key can decrypt the data. Greedy algorithm. These algorithms solve the optimization problem by finding the logically optimal solution, hoping it is optimal solution at the global level. However, it does not guarantee the most optimal solution. Recursive algorithm. This algorithm calls itself repeatedly until it solves a problem. Recursive algorithm calls themselves with a smaller value. Every time a recursive function is invoked, backtracking, backtracking algorithm. This algorithm finds a solution to a given problem in incremental approach and solves it at one piece at a time. Divide and conquer algorithm. These are common algorithm is divided into two parts. One part divides problem into smaller subparts. The second part solves these problems and then combines them together to produce a solution. Dynamic programming algorithm. These algorithms solve problems by dividing them into subproblems. The results are then stored to be applied for future corresponding problems. Brute force algorithm. This algorithm iterates all possible solutions to a problem blindly, searching for one or more solutions to a function. Sorting algorithm. Sorting algorithms are used to rearrange the data structure based on a comparison operator, which is used to decide a new order for data set. Hashing algorithm. This algorithm takes data and converts it into a uniform message with a hashing. Randomized algorithm. This algorithm reduces running time and time-based complexities. It uses random elements as part of its logic. Uh, Problems in writing a code for factorial. When the value of an changes increases by 1, the value of factorial increases by n. So the variable storing the value of factorial should have large size. Following is the value of n, whose factorial can be stored in the effective size. Integer n greater than or equal to 12. Long int, long int n greater than or equal to 19, less than or equal to 19. From the above data, we can see that very small value of int can be calculated because of faster growth of factorial function. We can, however, find the mod value of factorial of larger values by taking mod at each step. Algorithm for uh, finding factorial of a number. What is the factorial of a number? Product of all consecutive integer numbers up to n is called factorial of a number and is denoted by n factorial. For example, the value of 5 factorial is 120. Mathematically, when it is written as n factorial is equals to 1 into 2 into 3 into 4 into so on into n. For example, factorial of 5 is 5 factorial equal to 1 into 2 into 3 into 4 into 5 into 5 equals to 20. Algorithm for finding factorial of a number. Step 1. Start. Step 2. Declare the variable n. Fact I. Read the number from a user. Step 4. Initialize the variable fact equal to 1 and I equal to 1. Repeat until I less than or equal to number 5.1. Fact equal to fact into 1. I equal to I plus 1. Print fact. Step 7. Stop. Pseudocode for finding factorial of number. Read number. Fact equal to 1. I equal to 1. While I less than or equal to number. Fact equal to fact into I equal to I plus 1. And while write fact. Explanation. We first take input from the user and store that value in variable name n. Then we initialize a variable fact with value 1, that is fact equal to 1, and variable I with value 1, that is I equal to 1. Repeat next two steps until I is less than n. Multiply fact with current value of I, increment I with 1. At last, print the value of fact. Let's take an example. Let the input be 5. Explanation gets created by our algorithm is 5 into 4 into 3 into 1 into 1. So the factorial of 5 is 120. Factorial of a larger number. Factorial of a non-negative integer is a multiplication of all integers smaller than or equal to n. For example, factorial of 6 is 6 into 5 into 4 into 3 into 1 into 1, which is 720. That is n factorial equal to n into n minus 1 into n minus 2 into so on into 1. Factorial of 100 having 158 digits. It is not possible to store these many digits even if you use long int. Example, input 100, the factorial would be like some having 158 digits. So following is a simple solution where we can use an array to store each individual digits of results. The idea is to use basic mathematics for multiplication. Create an array result RES of max size, where max is the number of maximum digits in output. Initialize the value stored in res as 1 and initialize res size of result as 1. Do the following for all numbers x equal to 2 to n. Multiply x with res and update res and res size to store the multiplication result. How to multiply a number x with number stored in x. The idea is use simple school mathematics. We one by one multiply x with every digit of x, every digit of res. The important point is to note here is digits are multiplied from rightmost digit to leftmost digit. If you store digits in same order in res, then it becomes difficult to update res without extra space. This is why res is maintained in reverse way. That is, digits from right to left are stored. Initialize carry as 0 with the following. For I equal to 0, res size minus 1. Find value of r of res of I into x plus carry. Let this value be product. Update res of I by storing last digit of product in it. Update carry by storing remaining digits in carry. Put all the digits of carry in res and increase the res size by number of digits in carry. For example, and number 5, 1, 8, 9 is stored in rest as following. Rest equal to, as I said earlier, the number should be stored in reverse order. So rest equal to 9, 8, 1, 5. X equal to 10. Initialize carry equal to 0. I equal to 0. Prod equal to rest equal to 0 and x into rest of 0 into x plus carry equal to 9 into 10 plus 0 equal to 90. Rest of 0 is equal to 0, carry equal to 9. So in this way, we will implement the factorial for larger numbers. Thank you.